Now that we've finished with example number 4 and we've seen some of these rules in play, let's try to take a look at a slightly more complicated scenario with example number 5. If you take a look here at example number 5, you'll see that I want to take the derivative of this fraction, which has a square root of x minus 2 in the top and a square root of x in the bottom. Now this is a little bit tricky because if I go back and I look at all of the rules that we've established so far, none of these rules identify what exactly I am allowed to do when I have a fraction involved. There's nothing in there that tells me how to take the derivative of a fraction. So I really have two choices. I could either start to try to set this up using the definition of the derivative, that setting up my big scary limit, or I could try to simplify. And as we stated a little ways back, we note that simplifying before trying to take the derivative is always a good idea. So is there any way to simplify this before I just start trying to calculate the derivative directly? Well, one thing that I might notice here is that, and let me change colors. I can say if we simplify first, we see that the derivative here of this square root of x minus 2 over the square root of x could be rewritten by using the separation of fractions. Notice here I could rewrite this as two different fractions, square root of x over square root of x minus 2 over square root of x. I just kind of separated my fraction, I split it apart. Well, by doing this, I can go ahead and now try to rewrite this a little bit more. Square root of x over the square root of x is the same thing as 1. And 2 over the square root of x is the same thing as 2 times x to the negative 1/2. And with this, I can actually see how I can start to calculate my derivative pretty quickly. Notice, I can take the derivative of each piece using my difference rule. The derivative of 1 is a constant, and so that's just automatically 0. Over here, I have 2 multiplied to a function with x, so I'll use the constant multiple rule. I'll leave the 2 alone and just focus on the derivative of the x to the negative 1/2. That can be tackled with the power rule, and that brings a negative 1/2 to the front, and then x to a power that's negative 1/2 but subtracted by another 1. That would bring this to negative 3/2. So in total, I can see here that what I would be left with is, let's see, these negatives are going to multiply together to make a positive, and the 2's are going to cancel, so I think I would just be left with a positive x to the negative 3/2. And this would be a perfectly acceptable way to write your answer. So again, I have to make sure that I'm careful and that I don't attempt to make up rules that don't currently exist. And I should also notice that simplifying is a great way to get around complicated issues, like when I come across something that I don't have a nice shortcut rule for, and I'm not really interested in taking the derivative of this directly using the definition.